Okay, so let's take a look at example 3, determining an angle in standard position. You've been asked to determine the angle in standard position when an angle of 40 degrees is reflected, first in the y-axis, then in the x-axis, then in the y-axis and the x-axis. Okay, so let's start by drawing our coordinate system. And our angle of 40 degrees. Okay, and notice that your angle of 40 degrees is also a reference angle, right? Because it's acute, it's between the x-axis and the terminal arm, and it's a positive angle. So we also have a reference angle. Okay, so we're going to reflect this angle over the y-axis. Okay, so sometimes when we say in the y-axis, we can also say over the y-axis. Okay, and one way to do that is to so if we reflect it over the y-axis, we'll find that it's in the second quadrant. So one way to do that is to draw a semicircle that spans the first and the second quadrants. And then take a point from the x-axis, move it along to our terminal arm, we'll call it P. And we want to take this point and reflect it over into the second quadrant. And one way to do that is to draw a line parallel to the x-axis, and then where it intersects the semicircle will be our reflected point. Okay? And draw a terminal arm through there. And then we have formed an angle that goes through the first quadrant into the second quadrant, and we will call this angle theta. Okay, so by reflecting the point P into the second quadrant, we have also drawn in our reference angle. Okay, so it's been reflected into the second quadrant. Alright, so we want to figure out what theta is. We know that between the x-axis and the terminal arm here in the second quadrant it's 40 degrees. We know that a full semicircle is 180 degrees. So if I want to work out what theta is, I would go 180 minus 40, and I would get 140 degrees. Okay, so theta then is 140 degrees. Okay, so let's try this by reflecting into the x-axis or over the x-axis. Alright, so we draw our coordinate system. Our angle in standard position. And note also that it is our reference angle. Okay, so we're going to do this, use the same method that we did on the first example where we're reflecting over the y-axis. So we're going to draw ourselves a semicircle. This time, because we want to reflect into the x-axis, we're going to be reflecting our reference angle into the fourth quadrant. So our semicircle then we're going to draw through the first quadrant into the fourth quadrant. Okay, and we're going to take our point P, and this time we want to reflect it over the x-axis into the fourth quadrant. So we're going to draw a parallel line again, but this time parallel to the y-axis. And where it intersects our semicircle is where our reflected point P prime is. Alright, so we will draw a terminal arm through there. and draw in our angle and call it theta. Okay, so we want to find out what this angle theta is. We know that between the x-axis and the terminal arm it's 40 degrees. We know that a full circle is 360 degrees, so if I want to work out what theta is, I would go 360 degrees minus our reference angle, which is 40 degrees, and that gives me 320 degrees. Okay, so in our next example, we've been asked to do two reflections, one into the y-axis and one into the x-axis. So we will start as we did on our other two examples. Okay, so we want to reflect that over the y-axis, so we're going to reflect it into the second quadrant, and then over the x-axis, so it will get reflected into the third quadrant. So I'm going to draw a circle that will, well, part of a circle that will go through the first, the second, and the third quadrants. So it'll go like this. Okay, and then our point P is here. Okay, so like we did in A, we can reflect point P over into the second quadrant by drawing a line parallel to the x-axis, and then we can reflect it into the third quadrant drawing a line parallel to the y-axis, and so our point P is now in the third quadrant, and we'll call it P prime. Okay, so we will draw our terminal arm through there, and then we see that our angle is this one here. We will call it theta. Okay, so notice that you've drawn a straight line, okay, that goes from the first quadrant right into the third quadrant, okay? And so it's like a semicircle, right? So if we start at P and move along to P prime, that's a semicircle. So that's actually a motion of 100, or a rotation of 180 degrees. Alright, so we also, I forgot to draw this in, but you also have your reference angle now right here, right? And so theta subscript r is in the third quadrant here. Okay, so we want to work out what this angle theta is. We know that our semicircle is 180 degrees. So we know that up to here is 180, and we want to move it over to where our terminal arm is. That's another 40 degrees, so theta is equal to 180 degrees plus 40 degrees, which gives you 220 degrees. So theta is 220 degrees. Okay, so this ends our discussion on example number 3.